In 2017, something passed through our solar system that didn't come from here. It came from another star. It was the first confirmed interstellar visitor we'd ever seen. A piece of another solar system falling through ours, and as it swung around the sun and headed back out toward deep space, it did something it wasn't supposed to do. It sped up. Not from gravity. Something gave it an extra push, a measurable acceleration that gravity alone can't account for. And here's the part that still isn't resolved. Comets speed up like that too, but only when they're spewing gas and dust. This object showed no gas, no dust, no tail, nothing. It accelerated like a comet, with none of the things that make a comet accelerate. We have been arguing about why ever since. And the most famous explanation is one most scientists refuse to say out loud. Its name is Oumuamua, a Hawaiian word meaning roughly a scout or messenger reaching out from the distant past. It was found in October 2017 by a telescope in Hawaii, and almost immediately, astronomers realized this was something they'd waited their whole careers for. Its path through the solar system was the giveaway. It wasn't on a closed orbit like a planet or an asteroid. It came in on a steep, open trajectory, looped around the sun, and was already leaving at a speed far too high for the sun to ever pull it back. That trajectory could only mean one thing. Oumuamua came from outside our solar system entirely. It had been traveling between the stars, possibly for hundreds of millions of years before crossing our path. We had a few weeks to study it before it faded out of reach forever. And in those few weeks, almost everything we learned made it stranger, starting with its shape, which shouldn't be possible for a natural object. Oumuamua was too far and too small to photograph directly, but astronomers could measure its brightness, and its brightness was doing something bizarre. It flickered dramatically. Over a period of about 8 hours, it dimmed and brightened by a factor of 10. The only way an object does that is if it's extremely elongated and tumbling, turning broadside to us, then end on, then broadside again, like a bottle thrown spinning through the air. When astronomers worked out the proportions, the numbers were extreme. A body something like 5 to 10 times longer than it was wide, either a long cigar shape or a flat, thin pancake. Nothing in our solar system, no asteroid, no comet we'd ever seen, has proportions that extreme. It was unlike anything in our catalogue, a reddish, featureless, wildly elongated object tumbling through space from another star. And then it did the thing that turned a curiosity into a genuine mystery. Quick one. While that sinks in, drop a comment. When you first heard about Oumuamua, did you think comet or did you think something else? No wrong answer. Genuinely curious. Now, the acceleration. As Oumuamua rounded the sun and headed back out, astronomers tracked its position with extreme precision. And the numbers didn't add up. The object was moving slightly faster than gravity alone could explain. The discrepancy was small but unmistakable. A paper in Nature in 2018 measured it at a roughly 30 sigma detection, which in plain terms means this is real, not a measurement error. There is essentially no chance it's a fluke. Now, on its own, that's not shocking. Comets do exactly this. As a comet nears the sun, its ice heats up and erupts into jets of gas and dust. Those jets act like tiny thrusters, nudging the comet off its purely gravitational path. We see it constantly. So the obvious answer was, Oumuamua is a comet, quietly outgassing, and that's the push. Except when astronomers looked for the gas and dust, they found none. The Spitzer space telescope, one of the most sensitive instruments we had, stared at Oumuamua and detected no coma, no tail, no jets, no dust. None of the signatures that always accompany a comet's outgassing. The acceleration was there, the cause was invisible. that's the paradox that has driven this debate for years. An object pushed by something, with no visible sign of what's doing the pushing. And it's into that gap, that missing explanation, that one of the most controversial ideas in modern astronomy stepped in. Genuine question before we get to that idea. When scientists find something they can't explain, do you think they should float wild possibilities publicly or stay quiet until they're sure? Drop your take. This one actually divides the experts. Here's where the story splits the scientific community in two. Because to explain a push with no visible cause, you have two options: an exotic natural process we've never seen, or something that isn't natural at all. Most astronomers are confident the answer is natural, and in 2023, a team published what many consider the cleanest explanation in Nature. Their idea, Oumuamua, was a chunk of water ice that, over millions of years drifting through interstellar space, got bombarded by cosmic rays. That radiation can split water ice and trap molecular hydrogen inside the body. When Oumuamua warmed up near the sun, that trapped hydrogen escaped. And because hydrogen gas is invisible to our instruments and carries almost no dust, it could push the object without producing any visible coma. A comet venting invisible hydrogen. It fits the acceleration, it fits the lack of a tail. For many scientists, that closes the case. But not everyone is satisfied, and the doubts are legitimate. The hydrogen idea is plausible, but it's hard to prove for an object we can no longer observe. Oumuamua is gone, far beyond reach. Other natural explanations have been proposed and challenged. A nitrogen ice fragment, a fractal dust bunny, a hydrogen iceberg. Each fixes some problems and creates others. And in 2024, astronomers identified about 14 so-called dark comets, objects showing Oumuamua-like acceleration with little visible activity, suggesting it may be the first of a whole natural class. The honest scientific position is we have good candidate explanations, no confirmed one, and an object we can never examine again. And into that uncertainty stepped Harvard astronomer Avi Loeb. Loeb pointed out that one way to get acceleration from sunlight with no outgassing at all is if the object were extremely thin and light, like a sail. Radiation pressure from the sun pushes on a large, thin surface, the same way wind pushes a sail, and a thin, flat, artificial sheet, a lightsail, would behave exactly like that. From there, Loeb raised the possibility that Oumuamua could be technology, a fragment or a probe from another civilization. Most of his colleagues strongly disagree, arguing the evidence doesn't require it, and that natural explanations remain more likely. Loeb's reply is that we shouldn't rule it out just because it's uncomfortable, and that the only way to know next time is to look harder and faster. To be clear, there is no proof Oumuamua was artificial, but there is also still no fully confirmed natural explanation, and that gap is exactly why the argument won't die. Here's what makes this more than a story about one strange rock. Oumuamua is gone. We had a few weeks with the first interstellar object we ever found, and we'll never get them back. Every question about it, the shape, the acceleration, the missing tail, is now frozen, unanswerable, because the evidence left the solar system. But it was not the last. In 2019, we found a second interstellar visitor, Borisov, clearly a comet far less mysterious. And in 2025, a third one arrived, an object called 3I/Atlas, also from beyond our solar system. And early measurements suggest it too is showing a non-gravitational acceleration that astronomers are still working to explain. The visitors are going to keep coming. The new Vera Rubin Observatory, scanning the entire sky, is expected to find 1 to 3 of these interstellar objects every year, which means the next Oumuamua, the next chance to answer the question this one left open, could be discovered any night now. The first messenger from another star slipped through our fingers with its secret intact. The only real question left is whether we'll be ready when the next one arrives. If you want to be here when the next interstellar object is found and the debate reignites, subscribe. I cover these the moment they break. And if objects from the dark between stars pull at you, the last video was about Sagittarius A star, our galaxy's black hole, and the 2025 discovery that its axis is aimed almost directly at Earth. That one's already up.